Hello everyone, this is the video lecture for College Algebra, Math 1414, Section 10.2, Hyperbolas. So hyperbola looks something like this or that. After this, we're going to talk about parabolas, so lots of bolas. We have two new formulas. We got the x squared over your major squared minus, that's the new thing, y squared over your minor squared equals 1, or y squared divided by major squared minus, again, x squared over minor squared equals 1. So if you remember the ellipse formulas from 10.1, this is very similar, but there's always a minus sign between them. And that's the automatic way that you know that you're dealing with a hyperbola rather than an ellipse. So why is the major always in the front, though? See how I changed it and made the y and my x change? Right? Normally it was always x and then y. Well, now I'm just changing this because this is technically a positive version right here, yes? And because of that, my major is always positive, my minor is always negative. Major is always positive, minor is always the negative. And therefore, technically, because this is a positive, it's always the bigger one, and this is always the smaller one. But let me just give you an example of something weird that you might see. What if you had x squared over 2 squared minus y squared over 3 squared? Well, this is still the major. And why is that? Because it's positive. This is still the minor. This is still the minor. Why? Because it's negative. In a way here, I'm saying not just positive and negative, but because this positive 2 and negative 3, see it right there? Positive 2, negative 3. Which one is bigger? And it's this guy. This one is bigger. This one is smaller. I know that's kind of weird. It's not a magnitude thing. We're talking just on the number line. Which one's further on the right? Which is most positive? And that's how you determine which one is bigger. So just watch out for those little things like that. Your major's always in the front, so that's a little bit easier to kind of think of. And so whatever your major's attached to, an x or a y, you'll be able to understand what's going on. Now, as for the graphs, they kind of right now look like two parabolas or something. That is not the case. They actually follow these asymptotes over time, and the same over here. We're going to get to the asymptotes here later. Right now, I'm just kind of showing you some basics. There's also the formula for the foci, which is going to change a little bit, and all kinds of stuff. So we'll get there when we get there. Let's do some problems. So 10.2.1, I have x squared over 25 minus y squared over 4. My notes are a little off right there. Hold on. There we go. So this is good. This is good. So they say graph it and find all this stuff and whatnot. Well, you can see that my major, this is going to be an x major of 5, and this is going to be a y minor of 2. And so my x major, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and that's it. You start graphing it. You're basically done. If you have foci, they're going to be in here somewhere, kind of like how parabolas will be here in a minute. So great. Well, how do I graph this minor thing? Where's that 2 going to come in? It ain't here. The 2 is going to be part of the asymptotes, but then again, right now, we're not so focused on that. We'll get to that in a little bit, okay? So just primarily use your major, and you can see that this is negative 5 and 5. Good, walk away. And in fact, these are called vertices. These are called vertices. These right here, these guys are foci. The vertices are what they're actually asking for on my math lab, and so you can give it to them. It's plus or minus 5 comma 0. Again, just plus or minus the 5, and it's on the or the x-axis, so it's 0. Okay, so now for the foci, the formula has changed, and so it's c squared is equal to major squared plus the minor squared. If you remember that the ellipse formula had a minus sign, yet ellipses have a plus between them. hyperbolas have a minus between them, yet it has a plus sign here in this formula. So these are always opposites of one another, okay? Those signs are always opposites for ellipses and hyperbolas. So that's my new formula. Well, I have my major squared. It's going to be that 25. My minor squared is going to be that 4, so 29. C is equal to plus or minus square root of 29. I don't think that reduces. And again, because it's going to be an x major, it's going to be an x of value. There you go. We found our foci. Next problem. 10, 2, 3. I got y squared over 1 squared minus x squared over 36 is equal to 1. Why did I put a square there? It doesn't have a square there. It is 1 squared. I just was overthinking it too quickly. Notice that this is still a y major of 1. 1 squared is 1. Because, again, this is a positive technically. So that's a positive versus a negative. This is bigger technically, okay? X minor of 6. And you can graph this immediately. I know that this is going to look a little strange, but my y's are only going to be 1 and 1. There you go. Cool. And then that's it. Yeah, I know it's kind of dorky. It's a 0 plus or minus 1 for my vertices. Again, that's going to be these guys right here, your endpoints, I guess you can say. And your foci, we have new formulas for. So we got c squared is equal to 1 plus 36. I just immediately took those two values. We could do that to make it a little bit quicker. Square root of 37. And I don't think that reduces. So there's your two foci. Next question. Sorry, I was just getting mixed up there a little bit. So we got 10, 2, 5. My foci, they tell me my foci are 0 plus or minus 3. And they tell me that my vertices are 0 plus or minus 1. And if you're wondering, hey, what if I see this on a quiz or an exam? How do I know that it's a hyperbola and all that kind of stuff like that versus a parabola versus an ellipse? We'll talk about the parabolas here later. They're a little easier. But as far as hyperbolas and ellipses, ellipsi? No, anyways, 1 and 1, 2, 3, 2, 3. So my vertices are here. That's going to be the actual shape, the endpoints, but my foci are here. And that would not have made sense if I had 1 and 1 and made an ellipse, but then my foci were like way out here. On ellipses, your foci have got to be on the inside of it, like right here. Those are the proper places, not out there. And so obviously this shape doesn't make sense. It would have to be this guy here. So that's how you could distinguish the two, by just looking at some numbers there. Obviously, we have a y major in this particular case, and that's going to be the 1s. My c is equal to 3, and so let's do some math here. We got y squared over major squared, and x squared over the minor squared is equal to 1. Again, we already know that's a 1. 1 squared, 1. I don't know what my minor squared is, though, but I do know that c is equal to 3, which is my major squared plus my minor squared. And so I already have some of those. It's 1 squared plus my minor squared. Solve for m squared, I guess you can say. Move this over so you get a 2. So my minor squared is a 2. And that's actually good enough. You don't really want to do anything else. Actually, hold on. I messed up one thing. Sorry. Back. Right here, this is incorrect. It's c squared is equal to the stuff 3 squared, which makes a 9. I was going a little too fast. I'm sorry about that. Okay, now we're fixed. We fixed it. Okay. Always watch to the end. So when you move this over, you actually get an 8. And so when you square root both sides, you get a minus 2 square root 2. But they're not going to really care about that. This is good enough, and you're just going to pop it in directly. Oop, that's an x. Over 8 is equal to 1. And that's good for your equation. Okay, now we're going to start talking about asymptotes. So we got 10, to 9, it says the endpoints, I'm going to write this out, the endpoints of the transverse axis. What is that? 0, comma, plus or minus 6. And they say that the asymptotes are, well, there's one asymptote that is y equals 2x. So this is one asymptote, is that right there, okay? I'm going to tell you the other one's just going to be plus and minus, so it doesn't really matter too much there. What do they mean by this endpoints of the transverse axis? They're trying to say these are my vertices. So my vertices, again, are going to be where my, there you go, right here. So 6, -6. That's pretty easy. We already got that far. This is going to be a y major. 6 is my major. And now, if I'm wanting the equation, I'm wondering what is my x minor? And you cannot determine it from just looking at this thing. We don't have any foci, so I'm kind of lost. But I do have this asymptote, and so we have to work with that now. And so let's do the asymptote formula, okay? Your asymptotes, and this is going to be a little weird, so hang on tight with me. It's y equals mx. Not little m as in minor, as in slope times x. Okay, now keep that in mind. We're talking, this is like, you know, mx plus b kind of stuff, just without the b. So y equals mx. So keep that in mind with the slope, okay? I'm going to erase that part. My slope, if you want to make it distinguishable, it's rise over run, right? Times x. And rise is a y value and run is an x value. So I'm going to say this is my x, I'm sorry, my y distance over an x distance, and then again times x. Now this y distance and x distance business here, you can see I'm kind of going a little weird on you. The y distance and x distance, they come from the major and minor numbers. Okay? Now, I don't always know which one goes where, because this is a y value, this is an x value, always. So it could be y is equal to major over minor x, or it could be minor over major x. The main point, I don't care about which one it is right now, the main point is that it's a y on the top and an x on the bottom, rise over run, slope, okay? And so I have a y major in this particular case, right, of 6. And I don't know what my x minor is. Okay, so let's write that out. So I have 6 over question mark x, and that's my asymptote. Okay, well, funny thing is that I already know my asymptote is y equals 2x because they told me that. And so I'm really looking then at this, I guess, piece right there. I'm saying that 6 over something is equal to 2. And you guessed it, it's a 3 that goes there. And so my x minor is actually a 3 distance. It's an x distance of 3. And now I can finally set up my final answer. So my y major, again, this was a 6 squared. My x minor was a 3 squared. And when you simplify that down, it's a 36 and a 9. And there's your final answer. We're done. Now, asymptotes come in plus and minus. I didn't really say that. I should have done it up here. Plus or minus, plus or minus, plus or minus. It just wasn't pertinent to this particular problem, but we will definitely see that here on this next one, okay? And they won't let you forget that. So here we go. I got y squared over 25 minus x squared over 36 is equal to 1. Again, it looks smaller, but it actually is bigger. It's positive. So I got a y major of 5. I got an x minor of 6. And they want to know what are the asymptotes Find the asymptotes. Okay, well this is very simple because it's again rise over run, my slope, right? My y distance, this is a y distance, y of 5, and then I got my x distance of 6. Put a plus and minus in the front, slap an x on there, and there's your answer. Now, what my math lab wants in this particular case is wow, my notes are messed up. Okay, pause for a second. My notes are all messed up. This is totally fine. Whatever you see there is totally good. I don't know why I messed up my notes, but that's okay. This happens. Give me a second. Okay, I know it's not professional to do that, but whatever. My point is that I mess up too, and that's fine. Everybody messes up. So my answers on my math lab are going to be 5, 6x, and then blah, 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 other math, whatever word things, and then y is equal to a negative 5 over 6x. And so those are your two answers that you're going to be putting in to my math lab. Separate boxes. This is not what they're looking for. They're looking for this stuff with words and stuff. Okay, so that was pretty easy. We're going to be doing that again here in a minute. 81x squared minus 64y squared is equal to 5184. We saw something similar with the ellipses. I'm going to just divide this 5184 to the other side. And what you eventually end up with is a 64 over here, and you get an 81 over there. Wow, that looks like such a coinky-dink. Yeah, that's what it is. It's not a coincidence. It's just almost always ending up like that. So notice that we have, this is going to be an x major of 8, and this is going to be a y minor of 9. That's good enough. And what are they wanting here is to graph it, to find the vertices and all that kind of stuff. Okay, fine. So x major 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There and there. Vertices are those endpoints that we just drew, so plus or minus 8, 0. The foci, which they're always wanting, c squared is equal to major squared plus the minor squared. And we can just take our denominator 64 and 81 and start adding them. 64 plus the 81, which ends up with a 145. And I don't think that reduces, actually. So c is equal to the square root of 145, and therefore my foci are going to be plus or minus the square root of 145, 0. I don't think that reduces, so that should be good. I think that's what I got in my math lab. And then finally, my asymptotes. Remember that it's going to be my y distance over my x distance. And so if you look back, major minors, we got my y distance and my x distance, 9 over 8. And so this ends up being very quick, 9 over 8 x. Go ahead and make sure it's a plus and a minus. And I believe they want you to write it in separate boxes again. I don't know exactly why, but that's okay. We can do that. Two separate boxes, they'll provide them. You just type those in and you're good. Okay. Another one, 10 to 27. So this graph here, we're going to take a graph and then find the equations. I'm going to try to count this again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then they have this business going on here. So my vertices are at plus or minus 6, 0. That's an x value, so an x major of 6. So that's always good to know. They also provide an asymptote thing here. And again, I'm not drawing my asymptotes perfect every time, but they will have that. And I looked at it, and I found a point on the asymptote being 6, 2. And notice that it's like right above this, basically. So 6, 2 is a point on the asymptote. And that's going to help me determine the slope because I have basically a rise and a run. And so rise over run, you end up with a 1/3 x. Now, you could just use this. I think it's just a coincidence that that happens, but I'd rather you do this more generally in case something is different for you, let's say. I'm saying that because I have an x major, it's going to be major on the bottom this time because that's an x major, and my y minor. And so I'm getting at that y minor divided by x major is a 6 is equal to 1/3. Okay, my slope here is 1/3. And so I could solve for y minor. You move this over, and your y minor ends up being a 2. And so that's what you're going to be using for your equation. So x squared over your 6 squared, y squared over your 2 squared is equal to 1. Of course, simplify all that. And there's your answer for your equation. Another one, 10 to 55. So I've got y squared over 36 minus x squared over 4 is equal to 1. Oh my goodness, it's almost the same problem. And they want to know what's the domain and what's the range. And you can see that I'm not trying to skip out on some, different problems. This is definitely a different problem. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Notice that again, it's a y's, not x's. So what's my domain? Well, these guys are going to keep going forever, not just up, but also to the side. I mean, kind of like parabolas, kind of. And so your domain is going to be negative infinity to positive infinity. You're done. So that's a good thing. Your range, though, notice that we have from negative infinity all the way up until, what's that y value right there? Negative 6. And then we go from positive 6 all the way to positive infinity. But there's nothing in the middle. And so what you have to do is negative infinity all the way to negative 6, square brace, because we are actually touching there. Those are vertices, you're touching. Union, and then 6 to infinity, close it off. There's your two answers. That's what my math lab wants. So that's what you're going to type. Gosh, that's a terrible infinity. Close enough, you can see what's going on. They give you the graphs, so that really helps, of course. Last problem, 10 to 63. 225 y squared minus 2025 x squared is equal to 455,625. And they say, how far apart are the vertices? Vertices, how far apart? I know you can't read it, but I just said it. Well, first off, you're dividing this to the other side, and oh my goodness, I didn't even see it coming. How did I know that these numbers are going to be here? Yeah, whatever. It's such a common thing in math classes. It does not always happen like this, but it's just so common that it just happens all the time. Okay, well, whatever. You got a y major of the square root of 2025, and that actually ends up just being a plain old 45, which is kind of interesting. Because it's a y major, we got blah, 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 45, blah, 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 negative 45. My hyperbolas are looking worse and worse. They do not look like that. They look something more like this. And even then, that's not perfect. So what's the total distance between them? Well, it's 45 plus 45 is equal to 90, and that's what they're wanting for their answer. And that's all I got. Thank you very much. Have a great day.